everybody. This is part 2 of Module 3, Lesson 9. In this section, we're talking about the distance, rate, and time problems. Please make sure you have a copy of the notes that go along with this, as again, they are not the usual packet. Students will be able to write and solve equations. So, in the first part of Lesson 9, we talked about age problems. We used a chart. We had a chart created for us. We used the chart to help us organize the information. Well, again, we're going to use a chart. One thing that you need to know about distance, rate, and time is distance equals rate times multiplied by time. Rate multiplied by time gives you your distance. That is a formula that you will see in here. Many math classes and science classes that you'll be taking. This is also the types of problems that I know you guys can handle, but your parents, your adults, probably have nightmares about when they think about algebra. All right, two cyclists start at the same time from opposite ends of a course that is 45 miles long. Cyclist A is riding at 14 miles per hour, and cyclist B is riding at 16 miles per hour. How long after they begin will they meet? So picture them biking towards each other. They're two different ends of the course, and they're biking towards each other. They start at the same exact time. Right? One's a little bit faster than the other. So we're going to make a table. Right? So we're going to draw. And we're going to say cyclist A and cyclist B. We also know that rate multiplied by time equals distance. So two cyclists start at the same time, that's really important, from opposite ends of a course that is 45 miles long. So the total distance, remember when we were talking about the sum of ages? The total distance is 45. Cyclist A is riding at 14 miles per hour. Do you think that's rate, time, or distance? Cyclist A has a rate of 14. Cyclist B has a rate of 16. Now they leave at the same time, like maybe a shotgun start. They leave at the same time. And where will they meet? That means they're riding their bikes for the same amount of time. Because they're different rates of speed, one of them is going to ride a little bit further than the other, but they bike for the same amount of time. So that means time is going to be the same for both of them. All right, distance. So we're saying that distance is rate multiplied by time. So 14 multiplied by t is 14t. 16 multiplied by t is 16t. So the distance is the sum of the two bicyclists. And the sum, it tells us in the story, was 45. So 14t plus 16t equals 45 miles. So we have our equation. Stop and pause it and look at it again if you need to. These charts are a little confusing, getting all the information down into the right places. All right, so solving an equation. I've always said, first thing you do is distribute and combine like terms. We have like terms. 14 t's and 16 t's equals 30 t's, which will be 45. And then we undo constants. Do I have a constant in this problem? No, I actually don't. So then I undo my coefficient. What is my coefficient? It's 30. So I undo that by 1 over 30. Multiply both sides by the reciprocal of the coefficient. And that leaves me with t equals 45 over 30. Now, that number really doesn't make a whole lot of sense. But if I simplify it, I get 1 and 15/30. Still not a whole lot, but 1 1/2. So 1.5 what? T. So what unit of measure of time are we looking at? Miles per hour. So 1.5 hours. They bike for 1.5 hours. So once you have the equation written, it's not so bad. It's just getting that chart filled in to get to your equation. Let's try this next one. A 555-mile, 5-hour plane trip was flown at 2 speeds. For the first part of the trip, the average speed was 105 miles per hour. Then the tailwind picked up, and the remainder of the trip was flown at an average speed of 115 miles per hour. For how long did the plane fly at each speed? So we need to make our table. And we have the first leg of the journey and the second leg of the journey. And we know that rate multiplied by time equals distance. That's just something you're going to have to memorize. We also know it was a total of 555 miles and a total of 5 hours at 2 different speeds. So the first part of the trip was at 105 miles per hour. Then the tailwind picked up. The remainder of the trip was flown at 115. How long did the plane fly at each speed? At each speed. So I'm thinking that this wording is a little different than the previous problem. The previous problem says they at the same time. So the time that they biked was identical. But this one says at each speed. So I'm thinking the first leg of the journey was not the same amount of time as the second leg of the journey. So one of them is T, some number of hours. The second is the total time minus what the first one was. I'm pausing to give you a chance to think about that. Okay, so the total time was 5 hours minus however long that first leg of the journey was. Together, these two, the t and the 5 minus t, equals 5 hours. All right, distance, we need to fill that part of our chart in, is rate multiplied by time. So 105 multiplied by t is 105t. 115 multiplied by 5 minus t is 115 parentheses 5 minus t. 115 sets of 5 minus t. And together, the total distance was 555 miles. So let's write our equation. 105 t's and 115 sets of 5 minus t totals 555. So remember the steps. The first thing is to distribute and combine like terms. Well, I do have to distribute in this problem. So I have the 105t. I have 115 times 5. 5, carry my 2, 7, 575 minus 115t. And all that equals 555. So I distributed, and I have things to combine. I have terms to combine. 105 t's minus 115 t's is negative 10 t's plus 575 equals 555. Whew. Got a lot going on in this problem. It's every possible step, isn't it? All right, so then we've distributed, we've combined, and now we undo our constant. So what is our constant? It's 575. So negative 10t plus 575 minus 575 equals 555 minus 575. Remember, property of equality. If we start equal and we do something to one side, we must do it to the other side to remain equal. On the left side, we still have negative 10t. Do not drop your negatives. 555 minus 575 is negative 20. So now I need to undo my coefficient, multiply by the reciprocal of the coefficient. So it was a negative, it stays a negative. Flip it. So negative 1/10, negative 1/10. Do not drop those negatives. That becomes t equals 2. So what did we just find out? The first leg of the journey, the first leg was 2 hours, and the second leg of the journey is 5 minus 2, which is 3 hours. Together, 2 and 3 make the 5, the total time of the flight. So, a lot going on in here. You need to do it with the charts. Yes, there's other ways to do this, but the charts seriously, seriously, seriously help you organize the information. We will be practicing this in class. See you then. Bye.